Hello everybody and welcome to your video notes on Learning Target 5.2 at the meets level. This is Mr. Basil and let's get to it. So for this learning target, this is the last stop for naming and writing formulas. And so if you read the learning target here, it says I can determine whether a compound is ionic or covalent and then name it or write its formula. Okay. So this is where things can get a little tricky, but I'm here to help you along your way. So the two main types of compounds that we've been dealing with up until now are the ionic compounds and then the covalent. And then some people call these molecular. So if you hear me say that, really covalent and molecular, same compounds. So now, I don't know why that always likes to pop up. Let's move this over here just a little bit. So that way I have just a little bit more room. All right, so the first thing we have to refresh ourselves on is what is an ionic compound? How can I tell that that's that versus a covalent compound? So remember, on a periodic table, we got our stair step here. And then all the elements that are touching these are metalloids except for aluminum. And so everything on the left over here, these are your metals, and everything over here are your nonmetals. Hydrogen counts as being a metal, or a nonmetal, sorry. So really that one belongs over there. But as long as we have that in mind, an ionic compound is something that has a metal and a nonmetal. Okay, whereas the covalent or molecular compounds, those ones are only nonmetals. So nonmetals are the things that make up the covalent or molecular compounds. Let's just make a note of that here really quick. So ionic is metal and a nonmetal. Okay, and then then covalent or molecular compounds, those are nonmetal plus nonmetal. And then sometimes you have more than that too, so like plus non, etc. Right? You could have lots of nonmetals together and that's still a covalent or molecular compound. I do want to make a note though that there is one exception to this metal nonmetal for ionic compounds, but we'll loop back to that by the end of this. So let's look at some examples here. So let's look at SO2 or sulfur dioxide. Okay, so now you have to ask yourself, is this ionic or is it covalent? And to help answer this question, we have to look at the periodic table. So sulfur is right here, and oxygen is right here. So both of these are nonmetals, so that's how we know that this is going to be covalent. Okay, and if you had the name, this kind of also gives it away. The dioxide kind of gives you a hint that that is going to be that. Then we've got NaCl, NaCl, or sodium chloride. All right, so sodium chloride, sodium and chlorine together, those are here. I've got sodium and chlorine. I've got a metal and a nonmetal, so that tells me that this is a ionic compound. Okay. And when we have these two different kinds of compounds, it's also important to remember how you actually go about these. Let's go with this. No, black. So if it's covalent, the rule for writing the name and figuring out the formula, you're going to use prefixes for the rule. So the rule is use prefixes, right? That's like the mono, tetra, octa, and so on. The rules for ionic is, that's right, rule for ionic is charges. Right, so you're going to use the charges to figure out the right formula for ionic compounds. All right, I got a few more examples that I want to go through next. So H2O, water, favorite chemical, water. Okay, so water is kind of one that you gotta be careful of. So water is made of hydrogen and oxygen. So we've got oxygen, which is a non-metal. You gotta be careful because hydrogen is on the left side of the periodic table. So you might be thinking to yourself, that's a metal. But be careful. Hydrogen is a non-metal, just like what we said at the beginning here. So it's a non-metal and a non-metal, which makes it covalent. So you gotta watch out for that one. You'll notice that this isn't called dihydrogen monoxide because it's a special chemical. Some special chemicals get their own special name, though if we wanted to name it, we could call it that. Right, now we've got C3. Let's change that just a little bit here. There we go. C3H8O, aka propanol. Don't need to know that, but that's what it's called. So that one, we got to look at the periodic table, find carbon, hydrogen, and oxygen. So we've got carbon, oxygen, and then hydrogen, which is a nonmetal. So carbon is a nonmetal, oxygen is a nonmetal, hydrogen, all three are nonmetals. So this falls into one where it's more than two nonmetals, but still it's covalent. So this one will go over here, and we call it covalent. All right, I've got three more for you, so stay with me here. So I've got, not N, LiNO3, so lithium nitrate. If you're keeping score at home. All right, so lithium nitrate. I've got a metal, and then I've got two nonmetals. So this does fall into the category of, so lithium, that's here on the periodic table, and then N and O are both over here, so that works. So metal and nonmetals, this would be ionic. Now the other way to think about this is I've got a metal plus two nonmetals, or you can think about it like it's a polyatomic ion. Right? So nitrate is one of those that's listed here. Nitrate. So remember, in all reality, yes, we got a metal and a non-metal that make up the ionic compounds, but in reality, it's actually that it's made up of ions. That's really what it is. That's why it's called an ionic compound. So if it's made up of ions, that's also the giveaway. So I've got lithium, I got a lithium ion, and I've got the nitrate ion. That's what actually comes together to form this compound. Just another way of thinking about it. And then two more. So NaSO4, or sodium sulfates. Pause the video and see if you can answer this one on your own. I'm going to go over the answer now. So again, pause, try to do this one on your own. But this one is also ionic. Okay, because sodium is a metal, and then sulfur and oxygen are nonmetals. That's one way to think about it. But the other way, the better way to think about it is you've got an ion and a polyatomic ion. Those two together, you balance the charges, make them equal 0, and you're good to go. Now this last one is tricky. NH4Cl. This is ammonium chloride. Ammonium chloride. Now, this is one where the exception comes in. So notice that nitrogen, hydrogen, and chlorine, they're all nonmetals. Oops, I don't want to draw that there. Now this is where you're going to want to feel like, ooh, that feels awfully tempting to call it molecular compound, or what else do we call it? Covalent compound. This is actually an ionic compound. Now, before you freak out and you go, come on, Basil, you told me that it's always metal and non-metal. Yes, that's true, but remember the actual definition of ionic is if it's made of ions. So NH4 is an ion, it's a polyatomic, and then this would be another ion. So the cation here and the anion over there. The reason why I know that is because that's one of those special ones that you just have to remember that they come up from time to time. So notice that the polyatomic cations, they're all nonmetals. So nitrogen and hydrogen, nonmetals. Hydrogen and fluorine, hydrogen, oxygen, phosphorus, hydrogen, those are all nonmetals. So this is where the exceptions come in. So I'm going to go back up here and just add this in to my notes. Let's see. Let's go with this color. If you have a polyatomic cation, then it is an ionic compound. Okay? So, if you have a polyatomic cation, then it's an ionic compound. So here, NH4Cl, even though it's all nonmetals, that would still is an ionic compound because it's made up of ions. Alright, now this is the last part of the video that I'm going to be going over, which is reminding you on how they're actually formed. This is something that you do need to know. So this is a review, but it's just a good reminder of these things. So let's just call this how compounds are formed. Okay, so remember, covalent compounds, that's covalent. Co is like with, valent, valence electrons. So this is where they actually share their electrons. So let's do water, because water is a good one for lots of reasons. So this is one way to show a water molecule. I think you've seen them in the past like this, where you got like your electrons being shared between them. Same idea. You can think about it like each of these bonds has 2 electrons in them. They're sharing those electrons with each other. Now, when these bonds are actually formed, remember they're trying to share their valence electrons such that they have a full octet. That's really what's going on here. And you can think about it like this. So I'm just going to redraw this picture here to show how oxygen and hydrogen are really kind of more or less sharing these electrons. So you can think about the red dots like those are the electrons, okay? Hydrogen and oxygen they're both contributing an electron, but they're not completely giving up their electron because they need it still. And so you can think about it like it's 2 hands that are holding on to these things, and they're both pulling on these electrons in one way or the other. But the electrons aren't being pulled completely one way or the other, they're being shared between them. And so, whereas in an ionic compound, like I'm going to show you, the electron actually gets taken away, and then the opposite charges pull them together. There's no charges here. The electrons are just being shared between these 2 elements, the oxygen and the hydrogen. So just a little visualization of how the bonds are actually being formed and what the electrons are actually doing. So in an ionic compound, let's use NaCl as an example. So remember, this is, again, it's all about valence electrons, but the electrons are actually exchanged, and then the different charges keeps them together. So let's just do a Lewis dot for both of these, Na and Cl. Sodium has 1 valence electron, chlorine has 7. Okay, so now for these, what ends up happening is this electron gets taken away from sodium and it gets brought over to chlorine. When this happens, sodium is left with a full valence level, the electrons that are underneath, and chlorine now has a full level because it gained the extra electron. When this happens though, the negative electron and the protons in the nucleus, they end up not being neutral anymore. They don't cancel out, so I end up with an Na plus charge, like +1 charge, and then chlorine gains that, so Cl, and it has all of these with this one that came from sodium, and this one ends up with a minus charge because it gained that extra electron. So now these opposite charges cause these two to come together. The positive and the negative, the opposites attract, they stick together, and you end up with this, Na plus, and the Cl, 1, 2, 3, 4, 5, 6, 7, 8, minus sticks together. We don't write the formula like this, but I'm just showing that the positive and negative is what caused them to come together. All right, there we go. I think that's everything. Yes, that is indeed everything. Thanks for watching, and see you next time.